Alright guys, welcome back to the MonSec weekly workshop. This week we're going to be tackling the Bandit over the wire as an introduction to Linux, and then later on tackling the UTCTF challenges. But first off, if you guys aren't familiar with the Bandit over the wire, that is essentially something that's just an introduction to Linux. So it's something you can do completely through your terminal, well, for most levels at least. And alright, and you can access it just by going to overthewire.org/wargames/bandit, and we're going to be starting off with Bandit 0. But to start off with it, first thing we're going to actually need to access it is a terminal. And this one we're going to be using the Windows Terminal Preview just because I like that one. Yeah, well. Alright, let's get rid of that webcam for now. Yeah, no, we're just going to get rid of that webcam for now because I'm lazy. So, I'm going to be using the Windows Terminal purely just because I like that one better than the default one. What do we need to use is SSH, Windows Terminal PowerShell, or it already has it installed. If you're using the default terminal, however, you will need to install it or use something called the Putty client. To install it, all you need to do is go to Apps and Services, or Apps and Features, go to Optional Features here, search for SSH and install this Open SSH client. Once that's all installed, then you should be ready to go to SSH into the Bandit. So to SSH into the first Bandit level, we need to specify what particular Bandit level we're targeting. To start off with, we're going to be going for Bandit 0, so it's SSH Bandit 0 at bandit.overthewire. .overthewire.org, and we also need to specify what port we want to connect onto. And the reason why we need to specify what port is because otherwise we simply won't be able to connect because it will go from the default ports. You'll notice on Bandit it specifies what port we're connecting to, which is port 2220. Alright. And then we should be able to labs.overthewire.org. And once you connect to that one, then it'll pop that up the first time and adding it to your known host. It'll only pop up once. If you type yes, it should be fine. Then you type in Bandit 0 for the password for the first level. And just like that, we're into the Bandit. Alright. So once we're logged in, we need to go to the level 1 page. And if we go to level 1 page, it says the password for the next level is stored in the README in the home directory. So for how to see the files of the directory you're currently in, all you need to do is just type ls, and it shows you all the files. If you want a bit more information about all the files, and you do ls-la, and that gives you a lot more information as well as including any hidden files. That comes in handy for later. But for first, all we need to do is see the contents of the README file in the directory. And to view that, all we need to do is say cat README. And just like that, we can see the password for level 0. So if we double click that, and then if we right click that one, it copies because we're using Linux right now, and Linux doesn't have Control-C, Control-V because they want to be difficult within terminal. Well, the terminal's being bad. So now that we have the password, we can try and log into the next level. Easiest way to do that is log out of your current session, change the next one So targeting the user Bandit 1 instead of Bandit 0. And once it connects, I'll ask you a password. Paste that back in with another right click. And we should be good to go. And if you remember something we used last week, which is the CTF, we'll also have a bunch of challenges up. So, even though I'm not currently logged in on this one, what you can do is any flag that you find in Bandit will have a corresponding flag within the MonSec. All right. So first off, looks like there might be a few issues with the mic, so I might just switch that one over real quick. So switching over to the right thing. Alright, hopefully that's a bit better quality for the audio, hopefully. And what we're going to do now is we're going to continue on with the Bandit. So essentially, if you have any questions about anything that I'm doing right now, all you need to do is just chuck in the chat. We'll make sure to answer it at some point once someone brings it to my attention. The idea behind this is we're going to go through the first 10 Bandit levels. Similar to NATAS, there are 33 levels right now, and you can get points for all 33 on the MonSec CTF, even though the option to enter the flag for each of the challenges won't appear until you've done the ones before it. But anyways, we're going to start going to level 1, 2. You may have noticed as well, Bandit's really beginner friendly. They have helpful reading material, pretty much all the commands you need to solve the level right there. And if you're ever not sure what a command does, what you can use is use the man command, then type the command you want information about. Man stands for manual, so essentially just reading the manual. So for example, man ls just lists the directory contents of what you're currently at, which is what we used before. Alright, however, what we're looking at right now is Bandit level 1 to 2. And if we list all the files within the current directory, we see the one we want to access is the one with a dash file name. So here's the thing, if we do cat dash, it won't work because it's expecting a different type of input. So we need to tell it, we need to tell the system that we are specifically looking for a file with a dash file name. The easiest way to do that is to say that we want to look for a file in the current directory with that. To do that, all you need to do is a /dash. Dash being the file name, / meaning the current directory you're in. And if we do that, just like that, we get our password nice and easy. Copy and paste that one, log out, and we can start logging into the next Bandit. All the Bandit challenges honestly ramp up in difficulty a lot slower than the NATAS do. So you should be able to find you'll be able to smash your way through a lot more than you could with a NATAS. I think the first time I joined MonSec, I was able to get through like the first 10 to 15 in the first session just off Googling things and asking people lots of questions. Alright, so for the next one, alright, what do we got to work with? So if we look in the current directory that we're in, we need to open a file that has spaces in the file name. So that's a pain in the ass, and is pretty much against every convention you try to follow when you're naming files. But the issue with that being that if you try to say open spaces in this file name, it treats every single word like a different file that you want to open, which is kind of a pain in the ass. So we want to say treat it all as one file name. So what we do is just pop quotes around it. Easy peasy. And just like that, we get the flag. We can log out and go to the next level.
make sure you redeem these flags for points. They're not worth many points because of how straightforward they are in the early levels. But later on they do ramp up, and I mean, who doesn't want to be on the top of the leaderboards always, right? Like, we have a look at the scoreboard at the moment. Whatever points you get, they're going to be displayed here. Right, anyways, we are going on to level 3 to 4 right now, and we're currently on Bandit 3. Password for the next level stored in a hidden file in the in here directory. Alright, so if we list what we have in our current directory, we only have the in here directory. If we change to the next directory via cd, and then we see what's in here, it doesn't look like we have anything. But if remember the command I was using before, the ls-la, then that will list all files in directory regardless if they're hidden or not. And just like that, we can see that we have a .hidden file. So we can just open that one as normal. And just like that, we get a flag. Nice and easy, nice and straightforward, teaching you how to actually get around Linux and how to essentially find your way around and open what files you need. So accessing Bandit 4. Alright, so what are we doing for this one? Password next level stored in the only human readable file in the in here directory. Alright, so if we list all the current things in our directory, it's only the in here, so we want to change to there. And if we list everything that's in here, we have a bunch of files now. So there's two ways to do the challenge. The way that they're expecting us to do it is to essentially do it with trial and error, where you open every file. Whoop, don't want to do it that way. Where you open every file, see what pops out, and see what happens there. As you can see, that ends up pretty janky. And what we're going to want to do, however, is use something called the strings command. So what strings does is it only prints the readable characters in the files. They don't suggest this, but the easiest way to do that is to say print all the human readable characters in all the files in our current directory. We do that just by saying /*, just to say everything in the current directory. Be very careful when you use that, however, because if you have a lot of files in your directory or very large files, then you kind of get fucked. But if you notice, there are a few human readable strings in some of the other files, however only one is long enough to actually be our password. Is this the best string? Is this the best method? No, but it works. So we're going to go with that one because it's faster than brute forcing solutions. So now we can change up to Bandit 5 using the password we got earlier. Alright, so what are we doing for this one? Password the next level is stored somewhere in a file under the in here directory and has all the following properties. Alright, so if we change to the in here directory, how many files do we have? So that isn't even all the files, those are just directories that could contain a file. So what we're going to want to make use of is the find command. The find, pretty straightforward, it finds files. And if we use that just straight up, then it returns a lot of files. So we need to pass some flags to it to make sure it narrows down the files that it returns to us. So if we have a look at the properties of the file, it's human readable, 133 bytes in size, and not executable. So we want to find a way to find a flag that we can pass to the find command to actually find a file with all of those properties. Now, there's a lot of finds in one sentence. So if we have a look at the manual for find, if we scroll down a bit, we're able to find the flags for find. And pages tend to be a bit long. Alright, if we keep looking down. So right now we're looking at all the different flags that we can look at, and a bit further down we'll see a dash size. Alright, so dash size, literally all you need to do is say find dash size, specify what size you want it, and then what measurement the size is in. Because Linux is weird, or the terminal is weird, the B doesn't specify bytes, it's 512 byte blocks. You want to use C for bytes instead because bytes is what we need. So what we're looking for right now is a file with a size of 133 bytes. And just like that, we only have one file. And if we want to access that file, I'm not going to switch directly to I'm not going to CD all the way to that directory because I'm lazy. Instead, I'm just going to cat the file directly from here. And you may have seen there, I didn't type really fast. I use the tab button because typing is for lazy. Typing is people with too much time on their hands. I'm lazy and I use tab to autocomplete. That saves your life a lot more later on. Anyways, if we cat that file, then just like that, we got our password and we can log out and make our way to the next level. Nice and simple, and we're already up to Bandit 6. We're just zooming through these ones. Alright. Oop, did I not copy that password right? Neat. Alright, let's try that one again. There we go. Second time's the charm. Alright, so this time we are finding a file with more properties. So a pretty straightforward way to do that one is, so if we look at the man page of find, or if you saw that one we were looking through it earlier, there is a dash user flag and a dash group flag. And because the size is also another property, then we're going to be using dash size as well. And I'm also just going to scroll down the man page just to show you guys. So there's the group flag and the user flags all the way down at the bottom. Right down there. Nice and easy, so those are the flags we're going to be using. However, if we just try to do find dash user bandit 7 dash group dash group bandit 6, however, and a dash size 33C, nothing will come up. Because this isn't just in a directory underneath where we currently are, this is somewhere on the server. So we need to specify that we want to look everywhere on the server, not just where we're looking at, not just further down from our current server. So if we do find slash, that indicates to go from the main directory and essentially look down from that. So if we repeat all the flags we had earlier. So we had a bunch of stuff that said permission denied. However, if you'll notice somewhere in here, we actually had something that wasn't denied, and we actually says bandit7.password. That looks like something that we want to access. So there is a way to get rid of all this permission denied stuff, which I'll go through real quick. Because all the permission denied comes in a separate output to the main output. So that output, we can filter it into 2 and then greater than to filter it into something. And then /dev/temp. That is essentially a black hole that you can chuck files you don't want. Or in this case, we can chuck the output that we don't want back in there. And if we do that, whoop, did I spell that one wrong? Alright, let's try. Alright. So I must have messed up the directory slightly, but it's something along those lines. Anyways, if you do that one, what will happen is you'll only get the valid results returned as you're throwing away all the errors that came up. Anyways, we need to cat into this section here. So what we need to do is say cat that, and just like that we get our pass at the next level. So we can log out and hop back on into the seventh bandit. Alright, so if you read the level goal for this one, the password is stored for the next level in the data.txt file next to the word millionth. So if we open the data.txt file, it's a dictionary, meaning that we get a lot of results returned from that. But we don't want to see all the results, so I've just counted it out by pressing Ctrl+C. And to find a specific line in that, we can make use of the grep command. Because the grep just matches lines, prints lines matching a pattern. Similar to regex, if anyone's ever used regex before, and just as handy as regex. Regex is life. And essentially, if you didn't see how you use the grep command, there's two different ways to use it. You can either say the pattern and then the file, or provide the arguments for each different section. Alright, so for example, if we say the pattern of, we want to see everything that's next to the word millionth, or all the lines that are next to the word millionth, in the data.txt file, then that's as simple as it is. It just looks through the entire file for any lines that start with millionth, and prints us out that entire line. Alright, just like that, we can hop on to the next level. Alright, hopping on to Bandit 8. Yep. Make sure I copy the password right. Copying and pasting when you can't see what you're actually copying and pasting is really a pain in the ass sometimes. There we go. Second time's the charm. Alright, so password to the next level is stored in the data.txt file and is the only line of text that occurs only once. So again, we have a dictionary in our current directory, the data.txt file, and that has a lot of lines in it. And of course, the lines all aren't sorted either. It's just a lot of random lines. So, you may have noticed in the commands you need to solve this level, they have a really handy command that says unique. And if we're trying to find a unique line, then maybe using the unique command might come in handy. So if you have a look at the man page of the unique command, it says it reports and omits repeated lines. That sounds about right for what we want. However, if you read the description, it only filters the adjacent matching lines from the input. So it doesn't check the whole file to see if it's unique. It only checks the line next to it. Now that's a bit of a pain in the ass, because as we saw before, our file isn't sorted. But that would work if file was sorted, and if you notice, the other command they tell us to use is sort. And wouldn't you believe it, that sorts text files. So what we can use for that one is we can sort the file and then find the unique. However, if we sort it and then try to do unique, we'd have to find some way to either store the result of the sort, or to pass the output directly to the input of unique. Alright, and there's a way to do this in piping and redirection, just like they tell you to do in the helpful reading material. Because if anyone doesn't know what pipe is, it's that little weird vertical line that you sometimes see. And what that does, it essentially says, take the input from the left-hand side and make it output, and take the output from the left-hand side and make it input for the right-hand side. So if we sort data.txt and then pipe it into unique, then that says take the sorted result and put it into unique. And there's also one thing you need to be careful in unique as well, is it only omits repeated lines without any arguments, meaning you still will get once of each line unless you pass the flag to only show the unique lines, which is -u. So we need to make sure that we're doing -u after the unique command. So if we pull up what we were doing before, the sort data.txt, and pipe it into unique with the argument of -u, then just like that, we have one line that only occurs once. Nice and easy. So if we log out for that one, let's try it out, see if we got the right password. If you want to check if you have the right password, by the way, without having to try and log into the next thing, you can just try and submit it as a flag on the MonSec CTF, and if the flag works, then you got the right password. And copy that, paste that one in. I suck at copying and pasting things. That's what I've learned from this today. There we go. Alright. Level 9 to 10. So password, sort of next level in data.txt in one of the few human readable strings beginning with several equals characters. So if you notice before, they now tell us that we want to use the strings command, the one we touched on earlier, which only prints human readable characters. And if we're looking for a line that begins with several equals characters, that sounds like a password to me. Oh, that sounds like a pattern to me. And if we want to find a pattern, then we just use grep. So if you notice in the current directory, we have the data.txt file. And what we want to do now is we want to grep any equals from data.txt. And if you notice when I do that one first, it says binary file data.txt matches. And that's because there's a lot of content that matches that grep search, meaning that there's too much content for the terminal to even want to display, so it just says that instead. So what we want to do is we want to filter out all the human readable characters first. And if you remember from before, using the command strings filters out for only human readable characters. So if we go strings data.txt and pipe it into the grep, and just like that, we're going to allow lines that have equals at the front. Because if you notice, if you don't remember from before, the strings takes the output from one command and provides it as input to the next command. And because I was already providing input, then I didn't need to provide the file that I was looking for either. Anyways, we copy that command and try it out on the next password. And look at that, just like that, we're into double digits. So after this level, I'm going to take a short break and just see if you guys want to see more, if you guys want to see any more Bandit levels demoed after this, then just let me know in chat, and if we have time, then we will try and provide a quick in between, quick few more demos in between the advanced workshop, which will be beginning at 7. And if you guys need to go back over any levels, you just let me know in the meantime as well. And also don't forget to make sure to register your attendance at go.monsec.io/attendance to make sure we know you guys are all coming here and that we should actually keep doing these. Alright, so the path to the next level is stored in the data.txt file, which contains base 64 encoded data. Oh yeah, we have encoding. That's almost like encryption, right? Kinda. So if we cut the data.txt file at the moment, then you notice we have a lot of a lot longer string, and we have a few equals in there, as is typical from a base64 encoded thing. So if you have a look at the command you may need to solve this level, there's a command called base64. That sounds a lot like the encryption, so how about we look at what the base64 command does. And just like that, it says it encodes and decodes data and prints it to the standard output. And would you look at that, there's a flag right at the very top to say, use this flag if you want to decode. And you know what, I do want to decode something. So I'm going to say base64-d of data.txt. And just like that, we got our password. And let's double check that that password works on Bandit 11. And then we'll take a quick intermission and see if you guys have any questions. I really do suck at copying and pasting stuff in Linux. There we go. Yep, nice and easy, just like that. However, let's go to the intermission now.
In the sky, gazing far into the night, I raise my hand to the fire, but it's no use, 'cause you can't stop it from shining through. It's true, baby, let the light into the night. I raise my hand to the fire, but it's no use, 'cause you can't stop it from shining through. It's true, baby, let the light shine through. If you believe it's true, baby, won't you let the light shine through for you, for you, for you, for you, for you, for
Alright guys, so we might get back into whatever we were doing before, which is most likely the Bandit. Someone asked, are you planning on saving the VODs? Yep. So as Miniman explained, we have all our VODs saved on the YouTube channel, and for 14 days after the live stream, they will all be available on our Twitch channel as well, so just view on whatever's more convenient. Although if we are ever playing music, then that's likely to get muted on Twitch. So make sure you can watch our demonetized YouTube video instead. Alright. Anyways, in lieu of any other questions, I may just get back into a few more Bandit, just for another 10 minutes or so, until we have the advanced workshop just about starting. That one's going to be a lot more interesting than Bandit. It's not as much beginner friendly, unfortunately, but that comes with some upsides as well. Alright, anyways, so if we're getting back in the Bandit, pretty sure we're up to a Bandit 11, which is 11 to 12. This one's a little bit more different because we're actually handling some basic encoding. Well, basic encryption. And for this one, it's using ROT13. Now, the real easy way to do this is by using the by transposing it through commands here. However, you can also use something that we make use of a lot later, which is called CyberChef. CyberChef is great for anything that's even vaguely crypto at all, because it just has so many different features that you have more, that you can do more things than you can begin to think of with it. Alright, so if we grab the content that we need from it, which is just within a data.txt file, and that's a real ugly ROT13 text. Yep, give me all that. Copy. And if we paste that one into the output, and if we search for ROT13 here, all we need to do is just put it into the recipe, and just like that we get the password. So just like that, easy peasy. Oops, someone's Discord notifications are still going. Alright, so if we copy that one, then we can use it for the next time. Use that for the password of the next level. Make sure you're putting these in for flags as we go. Let's check, has anyone actually been updating their scoreboard recently? But in the meantime, log out of this current Bandit and log into Bandit 12. A lot of these ones are real trivial. Later down the line, they get a little bit more complex, and if you see later on, you can generally judge how complex they are based on how many points they're worth. Alright, so logging into Bandit number 12. 12 to 13. Alright, so what do we need to do for this one? Oh, it's this level. So, this level is a file that has been repeatedly compressed with different methods, made into a hex dump, and is a general pain in the ass level. First time I did this level, I think it took me about an hour to figure out all the different layers to it. There are ways you can make it shorter, but not that much shorter. So generally they provide you with every single different command you need to compress and decompress. Right, in the command you need to say command you need to solve the level. However, first thing we need to do, like they suggest, is create a temporary directory, because we're going to be decompressing a lot of files and we need places to dump those uncompressed files. So what we want to do is say make directory under the temp and name the directory whatever we want. In this case, this challenge sucks. Because it does. Oh, it exists, would you look at that? Alright, make sure we're saying it's the directory. That's odd. Alright, if we make a directory here called it just really doesn't want to play nice, does it? Alright, let's change back to root, try that one again. Why does it not want to create a directory? Why do you want to be a pain in the ass? Alright, let's... I should. Alright, we're on the right level, aren't we? Yep. Let's try creating that one more time. There we are. So the thing is that this is shared by everyone who attempts to do the challenge, meaning that someone's already used and made a directory called "This Challenge Sucks," which really just drives home how much the challenge really sucks. So what we've done is we've made our own directory called challenge tests, and we can change into that directory just by using cd. Yep. Capitals matter. And just like that, we have nothing in this one anymore, which is nice. And we are going to want to move the file that was in the root directory into the directory we were just in then. So what we can say is we can say move data.txt into temp challenge tests. Oop, did I mess up move? I think I did. Yeah, we want to copy it, not move it, so we want to copy data.txt into temp challenge. Test. Come on, I just created that. be why. Alright, I'm just going to do laser away and log out, log back in to get into the right thing. Alright, so let's copy the data.txt into the temp. Ugh, yeah, man. There we go. We finally got there in the end. Alright, so now that we're actually in here, we can start messing around with the file. So if we open the file to start off with, let's see what it contains. They tell us it's a hex sump to start off with, so we have a bunch of data here. So the initial way they really want you to do it is keep using the file command to see what the file is. And ASCII text, you can assume most times that it's going to be a hex sump. However, what you can do is use CyberChef, because CyberChef has something where they will automatically try to guess what compression it's using. So CyberChef, if you use magic and tell it to keep going down, then it will try and guess all the different ways in which the file is being compressed. So if you look in here, this is the one that they've gone the furthest with, which is from hexsump, gunzip, bzip2, gunzip, untar. That's only 5 deep, and I'm pretty sure it goes even deeper than that one. But we'd have to use each of those different commands in order and get the output from each of them to try and finally find the flag from it. I'm not going to do each individual one because that takes a bit longer than the time that we have at the moment. So what I'm going to do for the time being is leave you guys with knowledge that CyberChef will save your life in this challenge, and that this challenge is worth a lot more points than the ones previous to it and the ones just after it because of how long I expect it to take for you. In the meantime, don't forget to record your attendance right at MonSec. Go.monsec.io/attendance. Make sure you sign up if you haven't already. And in the meantime, I'm going to leave you guys until the advanced workshop starting at 7, where they're going to be tackling the UTCTF challenges. Alright. Thanks, guys.
Like a hell. Like a Hellcat.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger,
Alright. Hello everyone. Sorry about that, mic was muted. Welcome to our advanced workshop section. My name's Sam. I'm part of kind of MonSec. I'm not a committee member though, but Mariusz has graciously allowed me to do a little stream here about the UTCTF ECB challenge. We participated in the UTCTF a few weeks ago, and I completed this challenge, but I didn't complete it fully. So what I'm going to be doing is showing you a write-up version, but one that I've edited with different name variables so it's easier to understand. So first thing first is, there's my one there. We don't want to be running that just yet. I'm going to be creating a new one. So we'll just name it decoder2.py. Alright, and on another little command window here, we are just going to nano the server.py. So this server was given to us with the challenge, as well as a little netcat command that we could use to connect to it. I'll demonstrate that to you now. So if we go MonSec.io, and the port is 9003. I think you guys can connect to this one as well. So you can give it a shot if you want. Yeah, all it is you input a string, just do some random characters, press enter, and it gives you a little hex encryption. Basically what this is an electronic codebook. That's what ECB stands for. I only learned this during the challenge, so bear with me while I try to explain what this is. It's fairly simple. It's just blocks of ciphertext. So in our case, if we look at the server, it is 16 bytes, and each block is appended onto each other as it's encoded. So you'll see here that we've got a little kind of we've got 1 byte there that is randomly placed depending on whether you get a 0 or 1 here. Then you've got the plain text that's encrypted, and then the flag. So if you had 8, I think it's 8 characters. If you have 8 characters, then you'll get 1 block, then another 8 is another block, another. I'll quickly demonstrate that now actually. We can just quickly type in a single A. You'll also have some buffer at the end as well, that's why it's massive. But you can see here, like the first, I'd say about there, is what you've encrypted, plus even more buffer. If we did, let's do 16 A's here, because it's a 16 block encryption. So what's that? 1, 2, 3, 4, 5, 6. Wait, I'm gonna have to recount that. 2, 3, 4, 5, 6, 7, 8, 9. 16. You enter that, and if we did the same thing, you'll notice that the first block, the first 16 bytes, is exactly the same. I'm an idiot. If we did that again, and again, you can see here, yeah. So it already starts with 05, and it becomes a different ciphertext as soon as we hit. Where are you? Here. So you can see here it suddenly becomes. Oh, actually no, they're identical. I'm gonna have to do it once more. There we go. Now it's a different. So what's happened here is the string has been, well, the extra byte that we talked about earlier has been appended on and completely changed our identical ciphertext that we created here. Now you have to remember this ciphertext contains the flag as well as an extra buffer on the end. But, as soon as you add an extra A there, you're creating a 16 block plus an extra block. So this first block here is going to be completely different. So to counter that, we're going to have to create a script to be able to decode everything. If I can quickly show you guys a little website that you can look at just to I'm going to bring this new tab in front so you don't see anything else. Just type in ECB AES and you should be able to find, where is it? One moment guys. Just type in tutorial maybe that'll work. I think that's what we want to go with. Nope. Here we are. There's a little demonstration there that of this vulnerability is if you use AES with electronic codebooks, it leaves behind these visible artifacts like the outline of this penguin here. This is the famous ECB penguin. So what we're going to do is we're going to exploit that fact, and we're going to try and get each byte of the flag one by one through brute force. So if we get out of that now, we're going to nano a new, do we already nano decoded 2? No. Let's nano decode 2.py. There it is, yeah. I have a feeling it's on the other one. It is. Okay, so first thing we want to do is use the Pwn Tools library. If you haven't heard of that before, it's a very good little set of tools that you can use to connect to servers. So if you go from pwn import all, if you want to install it, just do pip install pwn in any command and you'll get it. We want a set of characters that we want to test against, so we're going to go test characters. Now you could programmatically do this, but I'm just going to hard code it, so A, B, C, D, E, F, G. Okay. Cool, and then you want digits, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and 0 as well at the start. You want these characters because they are the characters that could possibly be in the flag. So A, B, C, D, E, F, G, H, I, J, K, no, that's another G. Perfect. And the last bit, if I just check it out here. Actually, no, that's it. Cool. Okay, those are all the characters that could possibly be in the flag. And now we want to do the remote command from Pwn Tools. And this command just allows you to programmatically connect like you would using netcat. So you go CTF MonSec, nope, ctf.monsec.io, put in the IP as the first and the port as the second, as 9003. You want to then have a little flag global here that already has part of the flag in it. You know that the flag's going to start with MonSec and then the squiggly bracket. And you know that it's going to end with the closing squiggly bracket, you just don't know what's going to be inside. So you want to create a little brute force function, and we're just going to pass there for now. Then we're going to create a little while loop. So we want to go while flag, while the last character of the flag is not equal to the closing squiggly bracket like I mentioned before, then we want to do some code. So we're going to do a little if our brute force function equals -1, that's going to be our error code. Then I don't know, print, oops, sad. character not found. Cool. And we're going to print, if it doesn't find an error, then we're just going to print the flag at the end. So we want this little thing there, we want flag, percentage %s. This is all just standard stuff. Flag, perfect. Okay, so now we want to actually get onto the brute forcing part. When it comes to ECB, okay, 1 second. We want to just quickly pull in the flag as a global in there. I know, but when it comes to CTFs, use whatever is at your disposal. The first thing you want to do is, get what you usually would input into the netcat, which was, a bunch of A's, right? It's just a bunch of A's. So in our case, we want to do a bunch of A's, but we want it to be the length of 2 blocks. Remember, because one block has to be full of A's, and then another block has to be full of A's, and then the last little byte of that second block is going to be the character that we're brute forcing. We're going to slowly bring it down, so then our flag is in the second block, and we'll be able to get all the characters through there. So you just want to get length of flag from there. Great. And I'll just put a little comment here. So we've got an example. So you want 16 A's in the first block, and then you may have 7, something like that, in the second, and then you'll have whatever the flag is there, right? But it'll be concatenated onto that second block. Great. So now, oops, you just want to print data, so that's percentage %s A characters. Bam. Cool. So we're just doing that as usual input. Then we want to just grab the response from the server. So okay, first off we want to actually send it, and when we send it we'll always get a response afterwards. So we want to do this, and what we want to do is also grab the first 64 characters from that response. Reason being is because 64 characters is 4 blocks, and you're not going to get any more than 4 blocks in this challenge. Unless you put in a fuck ton of, a lot of A's. And then response 2, which is our little comparison, because remember we had a little random byte at the start there, which means we'll need to try and compare between the two before we're able to determine what the flag is. So that means we need to go while true, and we do the same thing as we did with response 1, we go and send those A characters, first 64, and then we want to just make sure that the 2 responses are not equal to each other. If they are, then they're the exact same, and there's no comparison there between one that could be with the random byte and one that might not. That's the main challenge of this challenge. We got to make sure that we're able to determine which is which. So our response 1 is, oops, that's nano for you. Response 1. And then we want to create response 2. Bring that in. Response 2. Perfect. Alright. So now that we're printing all that, we want to now, so now that we've got 2, but we don't know what our flag is yet. Now we want to be able to input our flag into a new input, so to speak. But what we want to be able to do is then compare our inputted flag without our inputted flag. So response 1, for example, is just this with the flag at the end there already. What we're now going to be doing is for char in test characters, because we want to loop through all the test characters. Our user input is going to be equal to a characters plus our flag, right? Plus our character. Okay. So I'll give you a little example here. Got 16 there. And then MonSec with the little squiggly bracket, which is our flag global up here. And what this is meant to do is then give us a little extra byte there at the end, because remember we're sending 31 minus the length of the flag, not 32. And so what that's going to do is it's going to leak the bytes of the flag one by one. Okay, now that we've got that, we want to then just quickly print. We're doing a test. Let's do a capital letter here. Test on %s. And we want to go bing, boom, user input. Perfect. We're just doing a test on our user input, and you'll see in a moment that what we're doing now is going to be identical to what we did above. So our res1 instead of response1 is the fsend, but with the user input instead. Fsend, by the way, is just a function that I'm going to create soon. It's just something that I'm condensing. And we want the first 64 of that. Then res2. Empty, again, exact same thing. Do a while loop in there. And we want res2 to equal, you guessed it, fsend of user input. 64. And, well, you can probably guess what this is going to be. It's not equal to res2, right? Because, again, we're still dealing with that random byte at the beginning. Okay. If that's the case, then we break because they're not equal. And yeah, that's it for this while loop now. Didn't mean to do that. Okay, now we just want to print the output of everything, really. So res1 is %s. Res1, just put a little space there. Res2, %s. You'll see the reason for why I'm outputting pretty much everything. It's just so then we can see how it all works visually once we're finished. So now we got a little if statement here. So now just got to do our comparisons, right? We've got to check to see if res1 is equal to response1 and res2 is equal to response2. Or we could check if for the opposites. So if res1 equals response2 and res2 equals response1. Great. If that's the case, then perfect. You found the correct character. And all you want to do then is just append it to the flag. Print it off. Bollocks. You guys didn't tell me anything. Were you watching the stream? That is a yikes. Apologies, everyone. Seems to me I had it stuck on a Medium article. Yeah, I did. That's annoying. Alright, I'm going to finish this, go through everything very quickly, and move on to Mariosh. So, we want to print our character found. Oh, we want a string there. %C because it's a character, and you want cha right there. Cool. Okay. fsend. Just a little function there. And what this is going to do is get rid of all the annoying text that we got while we were inputting. So I'll demonstrate it again because I don't think you guys saw it. You can see here that whenever we input something, it gives us some stupid junk text that we don't need, and we're just sifting through that with this. The only thing we want is our little hex string. So if we go back, we're just going to go r.send line after, and we want to get rid of the first one because that one is our little input string. It's telling us, oh yeah, when to input text. We want to then receive until, and we want to receive until that little smiley that you guys saw in the just before we got the ciphertext. And the last bit here, resp equals r.receive line and -1 right there, because we want to receive it up until the last character, which will be a new line character. Okay, and that's it. All we need to do then is just return resp. Alright, so for pretty much everyone, because of my dumbass mistake, I'll go through each line individually very quickly. So when we, well, first off we do pwn import. I believe you guys remember that pwn tools is very nice and useful for when you want to connect to servers, when you can't use netcat programmatically. Test characters, all the characters that will be in the flag. Our little remote function, same as netcat, but you know, programmatically. Our flag, we have the little start of our flag, always going to be like that, MonSec with a little squiggly bracket at the start. Our little brute force function takes in the flag because we're going to be editing that constantly through these fors and while loops. When we do this, here's a little example that I wrote in a comment. We are multiplying a by the well, 2 blocks of a minus 1, but then also minusing the length of the flag. So the length of the flag would be like this section here, for example. That's why we don't get a full block of A's on the second block. The reason why we want to use a whole block, by the way, up of A's, is because we get that random byte. When we get that random byte, this block of A's, or well, the whole ciphertext actually, it's going to be completely different. Then we print that data, we go, great, we want to send that to the server and get a response from that. And then we want to do it again and make sure that we get a different outcome, because either one could be the one with the byte, the random byte at the start. If that response, if those responses aren't equal to each other, great. You've got 2 different ones. The weakness behind ECB is the fact that you're only going to get 2 different ones. You're not going to get any more. If you didn't have that random byte, you would always get the same one, constantly. And it would be even easier to break into. This here is just printing those responses out. And then now, this is the brute force part. We're going through each character in our test characters, and we're appending it to this little bit of user input. So we've got our A characters, which we've defined up here. Then we're also appending the flag on, and then a character at the end. So what's going to happen here is we fixed that, by the way. We fixed that. Yeah, sorry about that. Yeah, so we're going to be appending the flag on and then the extra character, and you can see the little example here of what the input is going to look like. It's a whole block of A's plus a whole block again with the leaked byte right at the end. And supposedly, you know, well, not supposedly, actually, when you do the same thing as we did above, exact same bit of code, what will happen is if you compare the two, so the one with the flag inputted and the one without, because the one without is going to have that leaked byte in it. So now when you include everything there, the end of that, well, this and this are going to be identical, but instead you're actually going to be inputting the leaked byte in. As soon as you know what the leaked byte is, then yeah, you just append that onto the flag and you keep going through. Just bam, 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 bam. The whole challenge when it comes to this was the fact that there was that random byte at the end. And we just got through that by using a little while loop. That's all it was, just a little while loop. And this fsend, I've gone through that with you. We're getting the first 64 because it's only 4 blocks, and really, you're not going to get any more than 4 blocks. You only really need to fill up the start block in order to be able to get this to work. And this is our little while loop here. While the flag is, while the last character of the flag is not a squiggly bracket, then you keep doing the brute force. Ah yes, we want a little error code as well, don't we? Of course we do. So, we want to go and do else here. Else, and you just return. Pretty simple. Alright, now we'll test that. Okay, you just got to do python decoded2.py, and I'm almost sure this is going to be there's going to be an error in here somewhere. Yep, I knew I spelled MonSec wrong as well. Where are you? There you are. MonSec. Let's try that. Okay. Coming through some... yep, again. Error with my code, we fixed that earlier there. Try this again. Res, obviously. I'm hoping you guys noticed this error when we were just going through that recently. If you did, well done. This should now... oh, it's a bit buggy because I haven't really structured the prints well. And we're only going through A's as well. I know. Okay. We don't want the else here. Just run it like that. Because I'm pretty positive this is going to work. There we go. Nope. That's not. There we go. Okay. Flag. 1 sec. I think it should be working. Let's try it again. Yeah, let's try it again. Probably just problems. Nope, no problems. There's actually a bug here. Okay. I'll tell you what. Because this has gone on for long enough, I'm going to task you guys to try and find the error in this. And see if you can do it yourself. I have somehow produced an error here, even though everything is identical. So, let's see. Are you guys looking at the chat to see if anyone is responding? Yep. Good. Response 2, response 1. We're receiving the line, receive until, receive line after. This works, by the way. I don't think it's because of that. I'm going to be honest, I don't think it's because of that. I'll add it in anyway. Tim's pointed out that I've added a little backslash O here. The write-up included it, so I included it, but I figured it would be fine to get rid of it anyway. Yeah, see, it doesn't affect anything. Okay, so we'll go through this and see. Let's get rid of that just in case. So as soon as we find one, it appends it. Come back up here. Come back up here and we're like, oh, what's up? Huh, okay. This should work, guys, funnily enough. Try test characters, yeah. Did I use test characters in the wrong area? Nope. Nope, 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 nope. Response 1, res 1, response 2, response 2, res 1, and res 1, response 2. Backslash n text, where at? Return 0. Nicely done, Tim. Alright, we forgot a little return. Round of applause for Tim, everyone. Yeah. So there you go, and you can see there that it's brute forcing through each character bit by bit. Except it's not now anymore. It got through 3, so that's fine. See if you can find the problem with this code while we move on to the next. Thank you so much, guys. Yeah, I don't know what's wrong with that. You can change it on your phone, can't you?
Here you go, not me.
Get him in.
It's what are you changing to?
Hmm? Oh, I've had 9. What's it done?
I'll bring you to the light, and it might taste bitter when you're answering to God. You can call me killer as you look into my eyes. Nothing but a sinner. You won't get away this time. You won't get away this time. You won't get away this time. You won't get away.
Hello, I think we are live. Cool bananas. So I'll try not to stuff up myself, but let's see how that goes. So I'm Mariusz. I'm not sure if you can even see me. I'm going to be running over a buffer overflow challenge from the UTCTF 2020. So how can we actually use buffer overflows to control the execution of a program? I already have the pwnable executable, so we can just write things and it works fine. That's all cool. But maybe there's more to this application. So if we just hold down like a character for ages, which is the best way of testing for buffer overflows, and you just spam that, then we see we get a segmentation fault. That means that we access some memory that we shouldn't be accessing. So I'm going to be using this thing called Radare 2. So R2 and then pwnable, which is the file that we're trying to pwn. And then I did AAA to analyze analysis. And then we can do functions. So then we have the main function, so we can seek to the main function and then display the visual representation. So there we go. And we see that there is a call to get, which actually takes in the input, and then it just thanks us for the string. Great. Well, it turns out that we can control this program 100% if we just put the right things into the string. So I'm going to quit this. I'm going to do pwn cyclic and then something like 200 to get 200 characters with a particular pattern. So if you've installed pwn tools, then you can get this big string and have a look at which exact parts we're overriding. Due to having all these patterns, if we override something and we see a part of the pattern, we know exactly where we are up to. So let's do analysis while we're debugging with the -d flag, and then say that we're going to breakpoint at the main function. So debug break at main, and then we can debug continue. Cool. Now I'm going to view the visual format, and we see that we're up to this line. Very nice. Then I'm going to whack capital S or Shift S to step over each line and step over each function call, so that we don't need to worry about how puts works, because we don't care about that. And we get to get, and then we actually need the input, so we give this epic patterny string. We see that the stack has now our pattern all over it, so that's very cool. And then after we do the leave instruction and we get to ret, then we see that this is at the top of the stack, which means that this is the return address. So due to endianness, everything is like backwards. So we're going to have to grab, I believe, these 4 bytes. So pwn cyclic and then look up with the -l flag and say OX 62616166. Yep, and that's 120. So that means that we have exactly 120 bytes until we get to the return address. Once we can control the return address, then the program's basically ours. So I'm going to make an exploit Python script. So I'm going to use the pwn tools and say, okay, first the padding is going to be just anything times 120, right? So that we actually get to the return address. And then I'm going to say, okay, let's make the payload the actual padding, and then add on some 64-bit thing that I can control. So let's do like dead beef. That's always a classic. And then I will say, hey, how about we connect to ourselves on port 9999. And then we can send the payload, whoop, that's P, and then go into interactive mode. Awesome sauce. That's the payload, and yep, looks good to me. Now I'll go back to Radare, and I'm going to open it such that the program is actually networked. So let me just demonstrate what I mean. If we see what's in my profile.rr, we have this thing called the raron2, which can redirect inputs and outputs. So what it does is it, instead of taking normal console input, you can tell it, hey, actually listen over the network. That's going to make things a lot easier for us to debug. So I'm telling it to listen on port 9999. Now let's just actually run this. So if I give Radar the option to debug this profile, and then to actually debug the pwnable application, and it can't find it because I need the full path. Let me just fix that up. And home is spelled with 1M. Awesome. And now you think, hey, it's stuck. Well, actually, it's not. It's just listening for the network. So if we use netcat to connect to port 9999, then Radare starts up. And if we just continue execution as usual, then we can do whatever, and the program works and then continues and exits. So now we can debug the program with a separate script that can send things over the network so that it's easier to debug. Awesome. So let's just start that up and run our exploit script. Cool. And then let's analyze everything, break at main, and display where we're up to. And I didn't actually continue up to main, so let's do that. Cool. And then I'll whack Shift S or capital S to go through everything. And then we see that the get instantly gets complete because we're sending the information over the network with pwn tools. And we see all of our A's, and then dead beef, which is what we sent afterwards. Epic. And now we see that dead beef is at the top of the stack. Beautiful. However, then our instruction point register is updated to dead beef, which is not a valid address, so obviously we can't really do that. However, if we look in AFL, we see there's an awesome function called getFlag. Let's just have a look if that does what we want. And just to make things easy, I'm going to spoil the whole thing and say this grabs bin sh and tells the program to execute it. In fact, getting us a shell, not just the flag, and then we can grab the flag as we want. So let's get this address, shall we? Now, because pwn tools is so epic, we don't actually need to get the address ourselves. We can tell it to read the elf file, which is the executable file, so pwnable, and then tell it to grab the function getFlag, and that's called a symbol, and getFlag. Great. So we've got the address of the function getFlag. So now instead of going to deadbeef, which doesn't make any sense, let's go to getFlag. And let's run that after starting Radare in network debug mode. Great. That should work. So I'll analyze everything, set the breakpoint, continue to the breakpoint, and then display the visual output. And there we go. Now we're sending this address, which if you were paying a lot of attention, you would know is the address of getFlag. And then we return to getFlag. Yay, we win. Or do we? Because as soon as this instruction happens, suddenly we jump over this entire exec VE and their shell isn't executed. Oh no. Well, if you look more carefully, you actually need to... The first argument needs to be deadbeef because it is compared against deadbeef, and then if it doesn't equal, then it jumps over the whole thing. So we want it to equal. So how do we get the first argument to equal to deadbeef? Well, in x64, so the 64-bit architecture for most computers, the first argument is passed on RDI. So if you look, Radar actually tells you that. It says arg1, which is the first argument of the function, is at RDI. But how do we put things into RDI? Well, for that we use something very scary sounding called return-oriented programming. But in this case, we're just putting in one register, so it's not a big deal. Since we can control the stack, let's see if we can get something from the stack into a register. The easiest way would be by a pop RDI instruction. That tells it, grab the thing at the top of the stack and just plonk it into the RDI register. Easy. So let's tell Ropper, which can find our return-oriented programming gadgets, to search for pop RDI and give it pwnable. And there we have this cool address for pop RDI. Great. So now if we just go back to the script, we can say, okay, the address of pop RDI is this, and then we actually need to get the value that we want into RDI. So we can do that by telling it to return to the pop RDI gadget and then giving it the value that we want it to pop. So it goes to the pop RDI, it pops the value, and then it goes to the flag. So we want dead beef. So let's try that again. Run the script, analyze, set the breakpoint, continue to the breakpoint, and then let's step through. And now if you watch very carefully, we have this address at the top of the stack. So when you go there, ooh, suddenly there's a pop RDI instruction. That's exactly what we wanted, because that's exactly what Ropper found at this address. And now at the top of the stack we have dead beef. So as soon as the pop RDI instruction happens, if we look carefully into RDI, it becomes dead beef, and dead beef is removed from the stack because it's popped. And now suddenly we have the address of the function get flag, which is what we wanted, because that's exactly how we crafted our payload. And now we're in get flag. So let's have a look how we go. Let's step through. Hey, and now we've got the /bin/sh string. We step through, it prepares the call to exec VE, and then we have exec VE running. And then I'll just speed through this, because now we're actually running a shell. So if we do ls, suddenly entirely through the exploit we can run arbitrary commands, including seeing where this program is running from, which happens to be the same place I have the exploit. But in reality, once you figure something like this out from having the local binary, then you want to see if it works on a remote server. So let me just try to do this without screwing things up. Cool. Maybe it's running now. Oh, now it might not be running because I accidentally closed that terminal. 902. Yes, okay, so I'm running my own server, which is very similar to the UTCTF server. So if I give it something, then it tells me thanks for the string. So if I just update the exploit so that it goes to the actual server, which still happens to be my own device but a different port, and then we run that, it does all the stuff, and then boom, ls, and there's flag.txt, and then we can just read the flag or whatever, right? So we can count how many characters are in the flag and so on. Epic. Now if you want to try this at home, then we have ctf.monsec.io 9002, which runs the exact same server. So if you can hack our ctf.monsec.io server using this buffer overflow, you can get our own flag and submit that to the ctf.monsec.io. And that's that from me, except remember to mark your attendance on go.monsec.io/attendance. And if you want to give us feedback on our workshops, go to go.monsec.io/survey. Thank you very much.